Hello, everyone, and welcome to this quick introduction to A/B testing lightning lesson. I'm Ronnie Kohavi, and we will get started. I will do a quick intro. Then we're going to look at the pros and cons for A/B testing. When should you run an A/B test and why? We'll look at the necessary ingredients, how many users you need, called statistical power, what are you optimizing for, the OEC. And then I'll share with you some humbling statistics about our failure rates. We'll talk about Twyman's law, that skeptical law that you may have heard of. And I will answer the 3 top voted questions on the Slido that was shared. You're welcome to vote more. I will answer many of those that you vote high offline afterwards if you need that. So a few words about myself and my biases. I went to Stanford, got a PhD in machine learning. I was then director of data mining and personalization at Amazon, and one of my teams was WebLab, the Amazon experimentation system. I was then a technical fellow and corporate VP at Microsoft, where I led the analysis and experimentation team. We were large scale. To give you an idea, towards the end, every day we were launching over 100 new experiment treatments. So nice scale operation. I then went to Airbnb, led the relevance, personalization, and experimentation team. And then I co-authored this HIPAA book, and you can see it was translated into several languages from English, Chinese, Japanese, Korean, Russian, and Polish. For those of you that don't know why we chose HIPPO at the cover, it stands for the highest paid person's opinion. Sort of your goal is to inform that opinion with data and not necessarily just listen to the whims of the HIPPO. And there's a link here that will take you to all the history and how this term was popularized. I am going to start with a simple explanation of control experiments. You have users coming in. We split them randomly into 2 or more groups. One is the control or the existing system or the A, and then B is the treatment. It has some feature B. You collect the metrics of interest. This is really important to make sure anything that you can log that could be relevant, whether it's your own server timing, whether it's users clicking, hovering over something, all those things are good to log. And then, of course, you do analysis at the end. A/B test is the simplest control experiments. We have an A and a B. In practice, I want to encourage you to do ABN, where you have multiple treatments against the control, not just 2 variants. As you'll see, because of our failure rate, there's a good chance that one of those will surprise you and be better. Lots of names for this. Microsoft calls these flights. Google sometimes calls them 1% test, which is a poor name, because we do tend to split high proportion of users. It's 1% doesn't give you enough power, even at large companies like Google. Yahoo calls these bucket tests. Field experiments used a lot in Facebook Meta and in medicine. And of course, since you've seen the COVID days, everybody knows what randomized clinical trials are. These are all the same names for the same concept, and they just develop differently in different verticals. You have to run statistical tests to confirm that the differences that you get here at the bottom, which are always likely to be different. If you take users, split them into 2 and look at conversion rates, you will get different numbers. So the question is this different real or due to chance? And this is why controlled experiments are the best way to prove causality. This is the key word here. What you are trying to say is, are the changes that I've introduced in the treatment causing these metrics at the bottom to change? Okay. Again, are these changes that we introduce in the treatment causing, they're not just correlated, they're causing the treatment the change. By the way, if anything is unclear, feel free to put things in the chat. I did mute everybody. In the Q&A, we'll open that up. But right now, if you have questions, I am monitoring the chat. And of course, you're welcome to vote on the Slido that was sent in this meeting. Okay, so a few fun examples of correlations and why it's important for us to focus on causality. You can see somebody post something like this. Look how close the meteor came to taking out the visitor center. Okay, so when two things happen together, and we don't know which one came first, it is unclear. So let's look at a few other examples of common causes. So ice cream sales and drownings, and also death by sharks, are all correlated. So if you look at the graph of ice cream sales and you look at the graph of drowning incidents at swimming pools or death by sharks, they're highly correlated. Why? There's a common cause. Both just happen to occur during summer, so seasonality. If you plot the number of churches and the number of bars, they tend to highly correlate. Okay, that doesn't mean that going to church more or opening up another church is going to necessarily cause another bar to open up, or vice versa. They are just correlated with population size. If you look at reading ability and shoe size, if you have larger shoes, you'll see a beautiful correlation with better reading ability, and that is because both increase with age, at least until you're about 18. This is a fun one. There was a Forbes article about the daylight saving is one of the causes of global warming. No, they just both happen to increase at the 20th century. So these are all examples. You're going to see a lot of them in your real life. People see some correlation. They're going to claim causality. Most of the time, it is not true. Controlled experiments allow you to test whether the relation is actually causal or not. And this is where we get into the hierarchy of evidence. As you read some research article, as you look at some data, remember this fundamental idea that there are some things that we trust more than others. So at the top, we see randomized controlled experiments. This is A/B test, what we're talking about today. They're almost at the high. Really at the top are multiple of these. So if you're able to run multiple randomized controlled experiments, then we trust this more than a single one. As you go down, the trust level decreases. So if you have a controlled experiment, there is still a control group, but it is sort of natural that we think is close to random, or it is completely unrandomized, the trust level goes down. Then you have observational studies. Somebody observes a relationship, a correlation, does a cohort analysis. Hey, look, I'm looking at these cohorts over time, or something called case control. Those have a lower level of trust. And then finally, somebody gives you an anecdote, a case study. My mother thinks the site is wonderful or great, or the hippo thinks this is a great idea without a lot of data to back this up. Don't apply a lot of trust to these things. So one question I get a lot is, when you want to test for an intervention, okay, what can you do? And the answer is, it's an A/B test or a controlled experiment. It will show you that that treatment that or intervention that you introduced caused the change. Okay, let's look at medicine. There's an amazing history of medicine where, in the 1900s, there was regulation by bodies which are equivalent to the FDA today, and they said the physicians are the best people to determine if drugs are effective. Then over time, we realized, no, these physicians are not as good as we think. And in the early 60s, they wanted substantial evidence, and took several years for the Supreme Court to help get this done and say that physicians are not able to discriminate efficacious drugs from useless ones, right? And this is from the Federal Register, where they said uncontrolled studies or partially controlled are not acceptable evidence for the effectiveness of drugs. Okay, so we went from relying on experts to relying on scientific evidence that drugs are affecting. And in the US, this is how experiments are run with randomized controlled trial. So some examples of policy that people want to check. Do you pay homeless people? Does that help? You can run a controlled experiment. Advertising. How much do ads on website increase my sales? Initially, the numbers were massively overstated, right? You see studies with 800% increase. And then when you see a more controlled experiment studies, they point to much, much lower numbers. And I'm giving you these links. You'll when you get the deck, you'll be able to click on them and read the actual articles. So all these blue links are clickable references that you'll be able to click on. And then site performance. If I improve search, this experiment we ran at Bing by 100 milliseconds, do user click more on ads or other things? And the answer was absolutely. That 100 millisecond was worth $18 million for us. That's fun. That funds a large performance team. So this is when you should run an experiment, when you want to get an answer to, is my treatment causing something to change? What's a good summary of the advantages of controlled experiments? Well, first of all, I want to go and pound this through causality, right? What we are showing is that with high probability, we can never claim 100%, but with high probability, the changes in the metrics that we're observing were caused by the changes that we introduced in this treatment. 2, sensitivity. We can detect in controlled experiments very small, tiny changes to metrics. Okay, at Bing, for example, we could detect a 1 millisecond, 1/1000th of a second degradation to performance. Okay, and you want to detect small changes because you want to know, well, I did this change, did revenue go up or down, and did it go up by 0.1% or 5%? With the control experiment, you're able to detect small changes, and that is a huge benefit relative to any other method where you might be able to say, I can only detect, over 2% or over, 10% or something like that. And then the last huge benefit is unexpected consequences, right? Because the typical scorecard has a lot of metrics, you'll be able to realize that even though you want it to move conversion rate or some other metric, there are other things that are being impacted, and that leads to amazing insights. Okay, so our typical scorecards have hundreds or thousands of metrics in them to take advantage of these unexpected consequences, right? I'll give you one example. The Windows team came out with a new indexer that, gives you fast search. They tested it offline. They did wonderful. They wanted to launch it. We said, why don't you run an A/B test? We ran an A/B test, and boom, what a surprise. This kills battery life on laptop. Oops, right? That's the beauty of finding something that you did not expect. What are issues with controlled experiments, right? It's not everything is rosy. There are problems. The most important one, in my opinion, is the direction. If you don't know where you're going, any road will take you there. It's the OEC. The org has to agree on some small set of metrics. We call them the OEC, the overall evaluation criterion, under which they will judge the A/B test. Okay, it is hard. A lot of books just skim this. All the statistics paper assume there's a Y. In practice, it is a really, really hard problem. Okay, some people claim that their goals are soft or intangible. Recommend this book on how to measure anything. The scope of experiments, not applicable everywhere. We discussed some of the necessary ingredients. We're going to discuss more of them, but it is important to realize that you can't always apply an A/B test. Issues with controlled experiment. One of the issues that I want to emphasize is you get a quantitative result. We tell you A is better than B. This is the delta. And then people come back and say, wow, I'm surprised. And to understand the why, you're going to have to look at other metrics. You're going to have to look at targets. You may have to run 3 or 4 experiments around that area to understand what really happened. Then there are issues with primacy and novelty effects. If you change navigation on a website, you may degrade the customer experience temporarily because people are not used to this. Even if the new version is better, the initial result may show that users are in pain, but you have to test it for longer to see if they go over this pain and things are better. I will say a lot of people claim primacy or novelty effects for every time the experiment looks negative in the beginning. Most of the time, it just doesn't have any sort of long-term impact. It stays negative. This is a rare effect, but it does happen. Something to think about. Finally, if you are using websites with cookies, then you get into issues of consistency and contamination. Users may flip when they erase their cookies or use a new device or use an in-private window. So what are these necessary ingredients? What do you need to run controlled experiments or A/B tests? Well, there have to be these units. Typically, these are users, but sometimes we use other units, pages or sessions or other things, businesses. And you have to be able to assign different users to different variants. And the assumption is that there's little or no interference between them. And what I mean by that is if I assign user A to some drug, that fact does not impact whether B is given the drug or a placebo. These are independent assignments. And the fact that B got a placebo doesn't spill over to A, to the impact that the drug is doing on A. Here's a good example. We know from studies since the 1970s, they do this annual survey that married people are happier. Okay, here's a graph. Here's the average in red. Married people over the years from the 1970 to where this ends in 2022, married people as surveys seem to be happier. And then this is the graph for the not married people. Okay, but you cannot claim that marriage is causing happiness. It is very possible that unhappy people are difficult to live with. They sort out of the marriage market, right? So the causal direction here is not clear. This is a survey. Yeah. The second thing is you need to have enough users. I'm going to discuss this on the next slide, how many users you need. And then you have to have key metrics that are agreed upon, can be evaluated by the end of the experiment, and they determine if the variant is successful or not. So, for example, measuring happiness is hard. So we use surveys as a surrogate. But if you're able to measure engagement using clicks, that may be a good metric on a website. Okay, think about life expectancy. You have to run very long experiments to say, does this drug improve life expectancy? Okay, so how many users do you need? Right? First of all, the beautiful thing about control experiments, unlike many, many other mechanisms, is you can compute that. We have the right formulas. There's calculators out there to wazoo. What do you need is the metric. Technically, you need the variance of the metric, and you can just look at last week's data and say, well, this is the variance of this metrics that I care about. Conversion, revenue, anything like that. The second one is you need an MDE, the minimum detectable effect. This is a number that you have to come up with, and you say, I care about a 5% improvement to my conversion rate. Okay, this is where the trade-off happens, right? I can say I want to detect an absolute 0.25% to my conversion rate, which is 5%. And so it's a 5% relative improvement to my conversion rate of 5%. So I wanted to be able to detect an absolute difference of 0.25%. Now, the formula is such that smaller changes are hard to detect. And in fact, it grows quadratically. So if you want to be able to detect something half as big, you need 4 times as many users, and this blows up really fast. So somebody says, I want to detect any difference, 0.01% matters. Well, you might have to run the experiment for 5 years. There's a trade-off there. I see questions in the chat. Calculators, you can just query for a power calculator. And if you put this as a question in the Slido, I will give you some references. How do we know, Max says, how do we know that we have all the ingredients needed? Well, here they are. You can check. Can you assign users? Can you agree on an MDE? These are things that, yes, we can check in advance where we meet them. Then the last ingredient is you have to have some idea of the error rates you're willing to tolerate. Okay, this I would say for if you're just beginning in experimentation, just stick to the industry standards. These are 2 parameters. They're set to 5% and 20% all the time. I will not go into the definitions. They're technical, but they're there. I would just start with that. There's a question about the recording. Yes, this will be available. Both the slides and the recording will be made available. Sweta asks if the A/B test is best suited for small changes. For small to big, that's the beauty. You can detect small effects, and of course, it's easy to detect large effects. With large effects, you can use other mechanisms. With small effects, you have to use controlled experiments. So I want to take you through one example just to get an idea of how hard it is to detect small changes. If you're looking at a COVID vaccine, right, they want the MDE to be 50%. Right, a small percentage of people get COVID. If you take the vaccine, they want to reduce that probability that you get COVID by at least 50%. In practice, many of you have seen the data, it's 80%, right? At least in the beginning, and then it dies off. For that, it's easy. You need a few thousand people. If you look at the Pfizer experiment, it was run about 3,500 people. Easy. For a website, it's a lot harder because we're not looking for 50%. We're looking for 1/4% absolute change. So if you have a 5% conversion and you want to detect an absolute 0.25, which is a relative 5%, this is huge, right? 5% relative is, you can say, I'm increasing my revenue by 5%. Now you need 200,000 users. A lot of people get shocked. With small MDEs, you want to detect small deltas, you need a lot of users. Okay, and we'll address that. That was one of the top questions in the Q&A, so we'll address that at the end. What do you do when you don't have that many? So if you remember one thing from this talk, remember this: agree early on what you are optimizing for. Okay, let me leave this up for a few seconds. Agree early on what you are optimizing for. Okay, this is called the OEC, the Overall Evaluation Criterion. Getting agreement on that OEC is a huge step forward in the organizational and cultural challenges. Okay, my guidance: think about customer lifetime value. Short-term revenue is rarely a good metric for an experiment. Okay, look for success and indicators that the users are happy, and be careful with lagging indicators. Be really careful. I've seen a lot of people choose what we call watermelon metrics. The team is happy, they're all green, their dashboard is beautiful. Once you talk to the customers, they see red. Okay, and then the criterion, this OEC, could be a weighted sum of multiple factors. In fact, that's sort of the advanced stage where people initially start off by saying, I care about these 3 things. And then over time, they learn to trade them off, to say, I'm willing to trade off this revenue for this reduction in customer churn. Okay, so things like some conversion rate of some action, the time it takes to take some action, right? Think about the time to check out. That's a beautiful metric, because if you make that faster, users are finding stuff faster, they're having a better day. Visit frequency is one of the holy grails. If you get users to visit more, that's usually a good thing, right? So these are good metrics for your OEC. Now, here is the important thing. You have to use a few metrics. You cannot say, I care about 20 things. It has to be a small number. And we call this or Pfeffer and Sutton named it the Otis Redding problem. If you've not heard the song, I want you to listen to the word. When you give people too many metrics, they start to ignore them. They can't focus. Very, very important point. Now, it doesn't mean that your scorecard should have 3 or 5 metrics. You need to have a lot of metrics for diagnostic purposes to understand, oh, look, my conversion rate changed. My revenue is up or down. Why? Where do people click more or less? What happened in the pipeline? What are micro conversions that I'm seeing? That causes you to raise new hypotheses and then iterate more. Humbling statistics. We all build features because we believe they are useful. Right? It is very rare for somebody to say, let's build this because I think it will hurt the experience. But experiments show, and we have the data, that most features fail to move the metrics they were designed to improve. Right? Have this post, ideas rarely survive contact with customers, based on a similar phrasing from the military folks. Okay, so this is your data. This table shows you amazing data. The success rate of experiments at Microsoft when we started was about a third. Avinash Kaushik, a well-known blogger, says about 20% from his consulting. I worked at Bing. 15% of our experiments were successful. It's a hard domain to improve search. And once you get to a certain point, you can see a lot of ideas failing. This is really 4 lines here. Booking.com, Google Ads, Netflix, Optimizely, about 10% success rate. Okay, and then again, the last line is for me at Airbnb search. We tried lots of machine learning models. We tested them offline. They seem to do great offline. And then we deployed them in a true A/B test. Only 8% of them were actually successful and improved the metrics that we care about. Okay, in education, recent data shows that only 12% of interventions that are properly evaluated. Everybody can claim success based on uncontrolled experiments, but when they're evaluated properly in a controlled experiment, remember that hierarchy of evidence, only 12% are stat sig and positive. Okay, in drug design, right? Remember the FDA requires you to go through phases, and phase 3 is the randomized clinical trial. Only 10% that start make it to approval. Okay, so we joke that, as the experimentation platform owners, our job is to tell clients their new baby is yet again ugly, right? Everybody falls in love with their baby. Most ideas fail. And this has been documented many, many times. Max asks, what's defined success? So it's the OEC. Remember that OEC on the prior slide? You tell me what your success criteria is. If it is positive to the OEC and statistically significant, so less likely to occur by chance, that's success. Okay. I will give you some more information about how to estimate that. It's not as obvious as people think, but you can start off by saying an approximation of that is what you see are the wins. You will be humbled when you run controlled experiments. Mary asked a good question. Why is this number high? I attribute this more to the timing effect. When we started, this number came early in the early days of A/B testing. And Microsoft was used to doing a lot of research, a lot of studies before launching a feature. And when we A/B tested that, yeah, it had a lot of data behind it to say that this was going to be good. When you get to quick iterations and you try a lot of things, we believe it is more effective. Most of Microsoft has now moved over to the agile methodologies. You launch a lot of things as MVPs, minimum viable. You try a lot of ideas to see what works, and then your success rate is going to go down. Also, the domain is different, right? Search has been being improved for a lot, with a lot of data, with a lot of experiments running for years. We've hit the low-hanging fruits. Okay. Everybody says, I'm going to be different. I'm not going to have the success rate. I want to show you this just as a good illustration of, even when you know the answer, it's hard for our brain to capture it. So here is an A and a B, and this green bar posts a shadow. And it is hard for us to believe, even if I tell you that the shade of A and B is exactly the same. Our brain does not want to believe this. Right? It can help when I connect them. Now the effect goes away. Let me show you again without the bar, with connecting them. That shadow is confusing our brain a lot. The low success rate is humbling, but it is more likely that you will be similar to this somewhere in the chart, maybe in the 10 to 15% range, than you will be in the 30 or 40 or 50 range. Running a few minutes over, let me go to Twyman's law. I got 2 more slides. In the book Exploring Data, I love this introduction. They say perhaps the most important single law in the whole of data analysis. You all expect this E equals MC squared. Twyman's law says the following: any figures that looks interesting or different is usually wrong. And you will not believe how many times I've applied that to amazing success stories and showed that they were wrong. Okay, you see all these results that, hey, just make this change, round the buttons and you'll get a 20% improvement. No, that is a bogus result. We are biased to celebrate good results and investigate the bad results, but I want to introduce a bias towards saying if something looks too good to be true, investigate it, and you'll see that it is wrong a lot. So some tests that you must do if you run A/B tests, I can't go into the details, but there's something called an SRM test, sample ratio mismatch. About 10% of experiments, sometimes 8, sometimes 12, when organizations start with this, they'll find higher numbers. Those invalidate the experiment. So it's a beautiful test. And as over the last few years, I've seen vendors implemented, they report that about 8% of their prior experiments that they told their users are now being invalidated. You can run an AA test, which is like an A/B test, but there is no difference. And then ask yourself, is the system telling me 95% of the time, if you use the 0.05 threshold, 95% of the time that I'm not seeing a difference between them, a statistically significant difference. This has been one of the most useful tools to discover problems, bugs in the software, in the methodology, in the estimates of variance, and things like that. And then, of course, you need to build some guardrails for your own business to say, hey, if revenue improves, but fraud improves, I don't call that a success. It could be that somebody found a way to defraud me. You got to be really careful with guardrail metrics. So, summarize, the less the data, the stronger the opinions. Think about your OEC, make sure you're agreeing what to optimize. It's hard to assess the values of ideas, so listen to your customers, get the data, prepare to be humbled, because data trumps intuition. There are lots of cultural challenges here. Go carefully with the statistics. There are vendors out there that got it wrong. There are many, many companies that I consult for that get it wrong. Getting numbers is easy. I can report a p-value. Getting numbers you can trust is much, much harder. And then remember this experiment often. If you're able to triple your rate of experimentation, you will triple both your success and failure, but you launch only the successes. So accelerate innovation by lowering the cost of experimentation. Okay, before I go into the Q&A on Slido, I want to give you one commercial break. If you want to learn more about A/B testing, I teach 2 online courses on Maven. The first one is called Accelerating Innovation with A/B Testing. This is the flagship course, 5 sessions, 2 hours each over 2 weeks. Next one starts December 2nd. If you use this URL, which is unique to this presentation, the 5 people that will register will be able to get $250 off. Sure, I get that. Yep, I'll put this in the chat. Somebody wanna, that's the advantage of going live. You get this early, 5 people. And then there's an advanced topics. If you're, this is less likely for people that attend this intro, but if you know of somebody, if your organization has people that understand A/B testing but want to go advanced, this is 2 sessions time, 2 hours each, talking about advanced topics. Okay. We are now going to go into the Slido questions. I'm going to put this link again if you want to look at them. If you want to vote, I will actually answer a lot of the top ones after the meeting. Anything that has some top votes, I will answer. So feel free to continue to vote. Did I have a typo in here? Okay, I'll put this in the thing. I do have a, this should be intro. And then I'll also say there is a GPT that I created where I fed it my book and some of the lessons from the class. And so it can take a lot of questions and answer them pretty well. Okay, so for the next 10 minutes or so, we'll take the questions and then I'll open it up for anything else that is voted high or in the chat. So Gigi, let's see if person is online. I don't see them, but they asked, are early stage products make it difficult to gather enough users for A/B testing? Are there alternatives? And let me say a few things. One, I want to start with ideas that don't work. Okay. Using observational studies or what are called quasi-experimental designs, those don't work. Because if you can't do an A/B test, because of lack of data, because we have the formula to tell me how many users you need, and you realize you don't have enough users, you're going to need more users. You're going to need more users to have that. So that doesn't work. A/B tests have the high sensitivity and are the gold standard. Bayesian approaches. Okay. Heard a lot of people say, hey, I'll use a Bayesian approach. I'll give it a prior and then I can update it. And you do get smaller numbers with Bayesian. But the problem is you're an early stage product here. You don't have enough users. How will you have good priors? Most likely your priors are going to be off, or you're going to have to use what are called non-informative priors. If you use non-informative priors, you're back effectively into the same world where you need more users. Some people say relax this alpha threshold. This is the threshold for statistical significance. Even though we tell you industry standard is 0.05, why don't I use 0.10? It sounds like I'm only raising my rate from 5% to 10%. That is a misinterpretation of what these numbers are. Typically, if you choose an alpha of 0.05, you will have around a 22% false positive rate. Okay, so be really careful. If you raise it to 0.10, about a third of your results that are statistically significant will be false positives. Okay, and there's a link to the paper that explains all this in detail. Look, such loss, a third of the results are not trustworthy. That's loss of trust and detrimental to any experimentation program. I don't believe you should do that. So these are things that don't work. What does work? Okay, so the first thing is, if you don't have enough traffic, you may not be able to A/B test. I will be the first to admit this. Go look at industry best practices and say, look, Amazon tested everything. They chose something, just copy them. Okay, I worked at Amazon. Everything is A/B tested. There are beautiful sites, Evidu, Good UI, Guess the Test. They show you patterns, and then they show you results. Now, you got to be careful. Many of those are what's called low power. They're not trustworthy. But if you find the result has a lot of users, that gives you some intuition. And sometimes it's enough to say, look, there's 5 results for my change. I will learn from it. Okay. If you are going to A/B test, there are some options that will help you. I see some questions in the chat. I will let me finish the questions, and then I will answer these in the chat. But if you don't know what Bayesian testing is, then it's not, this is not the, you should know it exists, but it is too hard to explain in a few words. And priors is basically your prior belief. You're able to put a distribution on what the result should be, but we'll not get into that. So if you're A/B testing, some options. One, big changes, right? Don't go for the small tweaks that you won't be able to detect. You're going to have to say, we're going to go for bigger changes that we think have a probability of moving key metrics by more. Okay, so if you double your MDE, I'm going to say I can't detect a 1% change. I'm willing to go for a minimum of 2%. Then that lowers your sample needs to 25%, right? So you double the MDE, you only need 1/4 of the users, not 50%, as the linear expectation might be. There's a square or square root there in the denominator. Okay, use other metrics that are closer to the change, right? You're making a change in the homepage. Don't expect to be able to detect checkout conversion rate with the small MDE. But you may be able to check, are people clicking more on the funnel that I want them to go through, right? And there's a pitfall here. You got to be careful. We're assuming that, well, if we're able to get them to the second stage of the funnel, the rest of the funnel doesn't change. You have to validate that in reality. And then again, technically, you can lower the variance. So for example, use conversion rate instead of revenue. That is a metric with lower variance, but then you're ruling out the possibility that average order size changes, right? So if you are able to make that assumption, there's no reason to believe that my change will cause the average size to change, then I can use conversion instead of revenue. You can cap. So I'll call anybody that purchases over $100, I'll call them $100. That reduces the variance dramatically. Even going from number of bookings to just booker 01, that helped us at Airbnb. And there's a link to the article that talks about this. And then finally, there's a free lunch. Cupid is a methodology where you can use data before the experiment to say, okay, this is how I can adjust the metric I'm evaluating, and it is proven to always lower the variance. So you will need fewer users if you use this methodology, right? It may lower it by a small percentage. It may lower it by 50%. At Bing, it helped us by 50%. So instead of running something for a month, we could run it for 2 weeks. It was a huge impact to our ability to run experiments and iterate more quickly. Okay, I know some people have asked what is Bayesian. I'm not going to define it, but normally there are two methodologies for evaluating changes. One is called frequentist, which almost everybody uses. There are Bayesian approaches that a lot of people are asking, should we use them? My answer is use Bayesian if you have very reliable priors. If you know what things are going to look like before you make the change. If the priors are correct, then you can update them with the data as it comes in the experiment. And the proof is that if you were correct, you're going to stay correct. The problem is nothing is guaranteed. What if your priors are wrong? And remember the success rate, we're often wrong. The nice thing about the frequentist approach is it gives you a guarantee. It says, look, here's a procedure. If you follow this procedure, you will have at most this alpha error rate, this 0.05, right? So if there is no difference between the control and treatment, I will only 5% of the time claim that there is a difference. That's called type 1. And then the other direction is if there is a difference, a true difference, do I have the power to detect it? And this is called beta, and normally, or 1 minus beta is power, and normally power is set to 80%. So I'll be able to detect a true change 80% of the time. Given how often we are wrong, I have doubts about the reliability of the priors, and therefore I generally prefer the guarantee, and I go with frequentist. If you use a Bayesian approach and say, okay, I'm going to be very careful, I'll use uninformative priors, which allow, say, I really don't know what's going on, then the results will be similar. Again, these are links you can look at. Guido Imbens, economic Nobel Prize winner, wrote this, which I think is a nice statement. He says, in the end, I do not see the advantages of Bayes factors over p-values as sufficient to convince researchers to adopt this technology more widely. So this is a minefield, lots of questions, lots of people claim one way or the other. I tend to go frequentist, and this is mostly what you'll see coming out of experimentation platforms. Last question, what are favorite must-read books on your bookshelf? Here is the link. Here are some books that have changed my life when I read them. So we are at time. This is supposed to end at 8:45 Pacific time, 45 minutes after the hour. I am more than happy to stay longer, but I realize some of you may have to leave, so don't be offended to leave. I will now look at the Slido questions and see if there's anything new, and then also address some of the chat questions. So the first three have not changed. And then the next one is, what would you consider a golden standard for running A/B tests, and when is it worth relaxing the confidence power? So the gold standard is that you set your alpha and beta at the industry standards of 5% and 20% or 80% power, and you do these tests for sample ratio, and you run AA tests. And when you do that, you will accelerate your innovation. Things will be amazing. If you try to relax these, there are papers out there on the problems with low power. You get into this issue where your false positive rate is going to be really high, and you lose trust in the system. I'll answer one more question here that's now just got its third vote. For the OEC, would you focus on immediate one like CTR to show direct user interaction, or long-term ones such as 7 to 14 days retention? The goal is long-term. So retention is a great metric in theory if you have enough data. In practice, it is a lagging metric, very hard to detect changes in an experiment. So a good example is Netflix. They're able to measure retention because they have this 1 month renewal, but they found a surrogate, which they believe is causally impacting churn, and that is streaming hours. Right? So they went with streaming hours as their OEC. And this is more complicated because you just don't go with the number, because taking somebody that's already watching 50 hours to 55 does not have the same impact as somebody that goes from 1 hour to 6 hours. So you have to think about how you threshold and create these buckets of streaming hours. But that's a good example of finding a surrogate metric that is able to change in an experiment, that you will see a change, you'll be able to get statistically significant result, and that you can show is causally impacting churn. Okay. ASR asks in the chat, I'll just take this last question. If you get an overall non-significant result, should you still segment users to see if there's a significant? Yeah, so this is called segments of interest, or in statistics, heterogeneous treatment effects. I love to do this, but now remember, as you start to look at segments, you are looking at fewer users. You're also suffering from what's called multiple hypothesis testing. This is a good way to get insights. You cannot launch based on this. Generate insights from it, do now a new iteration given the insights that you got, and then if this replicates, you're good. But be really careful about, you can always find small segments that have large effects. They're just not trustworthy. They suffer from what's called the winner's curse. We will end here. Again, I will answer the Slido questions that have a few votes. So if you want to vote something or read, I will answer these. And hopefully you have learned something new and enjoyed this. Thank you, everybody. And we will end right now.